In today's video, we wish to review Module 2, Unit 2, Test Version 1A, Standard A1 SEI.2, Systems of Equations by Substitution. Let's take a look at number 1. Remember in substitution, and we talked about this in class if you remember, means replace. When I'm gone as a teacher, someone comes in and takes my place. I'm gone, and they're where I'm supposed to be. That's what we want to do in substitution. Notice here in number 1 that we know that y equals 2x minus 1. That means for any other y, we can replace. So 2x minus 1 equals 7x minus 11. I simply take out this y, and I put what the equals in its place. And the whole point of this is to get an equation that just has the variable of x. So now we're solving this little equation with variables on both sides. So the left side, notice, has the least amount of x's, so I'll take away 2x. Negative 1 equals 5x minus 11. We can then add 11. And again, you guys did this all throughout module number 1. Dividing by 5, we find out that x equals 2. Then, of course, remember, we substitute that back in. I'll go to this bottom equation where it says y equals 2x minus 1. I'll put 2 in where the x was, 4 minus 1, y equals 3, and thus the answer becomes 2, 3. As we take a look at question number 2, notice in this case that we don't have anything by itself, but we'll look what we can do. Y minus x equals negative 2. Well, we can solve for the y, and to do that we add the x to both sides. Notice they're not like terms over here, so we can't put them together. We just simply have to list them out as x minus 2. Now that I know that this is going to go in for this y, so x minus 2 plus x equals 4. I replace y with what it equals, which is x minus 2. I have like terms. 2x minus 2 equals 4. Add the 2. 2x equals 6. And x equals 3. Of course, we have to plug it in because we have to find both the x and the y. So now that I know that x equals 3, I can replace this x right here and x minus 2 with 3, and y equals 1, and our ordered pair answer becomes 3, 1. Now as we take a look at number 3, once again, notice that we don't have anything solved because there's no variable by itself. But notice here that our x, notice here in our top equation, the x is by itself. You always want to look when you do substitution to solve the equation for the variable that's alone. So we'll add 6y, because our goal is solving is to get the variable by itself, and find out that x equals 6y plus 16. So again, we can now make a substitution, so let me change colors. This equation, 9, we're going to replace the x, and it equals 6y plus 16. The rest of the equation will stay exactly the same. Minus 2y equals negative 12. We can distribute 54y. 9 times 16 is 144. Minus 2y equals negative 12. Combine the like terms. So I move this over here because I'm out of space. The y's are like 52y, because 54 minus 2, plus 144 equals negative 12. We'll then take 144 away. 52y equals negative 156. And y equals negative 3. Again, we need both the x and the y. So x equals 6. We'll replace the y with the negative 3 plus 16. So that's negative 18 plus 16, and thus x equals negative 2. So our ordered pair answer, remember, we always write our answer as a point, -2, -3. Question 4, again, we have to write our own two systems of equations here. The sum, and we should all know that sum means addition, of the measures of angle x and y is 90. X plus y equals 90. Now the second equation is what was tripping us up a little bit. If the measure of x is always means equals. 30 less than, that means subtract, twice the measure of angle y. So x equals 2y minus 30. To get twice something, we multiply it by 2, and we are less than. So we can see, this is clearly set up, that we know that x equals 2y minus 30, so I'm going to take out the x, and in its place I'm going to put 2y minus 30 plus y equals 90. Because here was x, I put out, take it out and put something in its place. Solving for y, again you have like terms, so 2y plus y is 3y. Then we're solving for y. 3y equals 120, and thus we discover that y equals 40. Again, remember you have to get the x as well. So 2 times 40 minus 30, that's 80 minus 30, and x equals 50. 50 and 40. Our final question on this standard is number 5. Again, we have to write our two systems of equations. A rectangle has a length that is, so as soon as I see my is, I know I'm going to put an equal sign there, 6 centimeters less than, so we'll subtract, twice the width. So we'll let x be the length, we'll let y be the width. The length is x equals less than, 6 less than, twice the width. Second part, the perimeter. Remember, perimeter is the sum of all the sides. So if I have a rectangle where x is my length, w is my width, again, this would be an x, this would be a y. Perimeter is found by adding all the sides together. So I have x plus x is 2x, y plus y is 2y, and our perimeter is 66. And again, this is set up for substitution because we know x equals 2y minus 6, so I'm going to replace this x. I'll put 2y minus 6 in its place. So that's 4y minus 12 plus 2y equals 66. Again, you have like terms. 4y and 2y can be combined, that's 6y. Again, notice I don't move them over, don't subtract on both sides, just combine them. Add the 12 over, 6y equals 78. We discover that y equals 13. Again, we have to know the x though, so we put 2, 13 minus 6. 2 times 13 is 26, and x equals 20. And our ordered pair answer, 20, 13. And that's how we do substitution.